We're going to look at how we can derive some double angle formulae. But to start with, let's look at the unit circle and properties that we can get from it. So I'm going to draw a circle here of radius 1. Now we've got a point here, so an angle theta anti-clockwise. And so we can define its x and y coordinates to be, and this is a definition of cosine theta and sine theta, so its x coordinate is cosine theta, and its y coordinate is sine of theta. So if I call that point P, then P in this axis, so if this was the x and y axis, then let's say we have some vector r. This could be written as cosine theta on the x term and then sine of theta for the y term. So this is a definition of sine theta and cosine theta. Well, these are the definitions for them. Now, if we wanted to get tan, what we could just do is we could extend from here. So we could draw a tangent meeting this, and then the length of this tangent would be, well, if this is 1, length of this tangent would be tan of theta. Or another way you could do it is if we extended a tangent from here, and we carried on the radius here, then we know this is equal to 1, and we know this height is equal to tan theta also. So that's different ways of getting the tangent theta function in terms of these. So what we could do is find a relationship between cosine of theta plus alpha and sine of theta plus alpha by rotating these axes. So what do I mean by that? Well, what I'm going to do is I'm going to draw a set of axes for x and y. And then I'm going to draw another set of axes for x prime and y prime. So these are two axes which are related to x and y. But all we've done is we've rotated by an angle alpha to get from one to the other. And so what I'm going to do is I'm going to write a point here that's an angle theta to the x-axis. So it's an angle or an anti-clockwise angle of theta to the x-axis. I'm going to call this point P. And I'm going to say that because P in terms of x and y is going to have cosine theta and sine theta. And this is in an x and y basis. So it's on the unit circle, so it's still got a length of 1 from the origin. But in terms of x and y, we could write it as this. But we also know another way that we could write this is in terms of the x prime and y prime. And P is going to be an angle of theta plus alpha from the x prime axis. So we could write this as cosine of theta plus alpha and sine of theta plus alpha. But this is no longer in terms of x and y, this is in terms of the x prime and y prime coordinates. So it's the same vector overall, so these two vectors are equivalent, but they're represented in terms of different axes. So we can use this now to find a relationship between them. And what we're going to do is we're going to pick a point along x. We're going to call this x hat. So it's a vector of length 1 in the x direction. And this is 1, 0. And then we're going to pick a vector here. This is 0, 1, and we're going to call that y hat. So it's a length 1 vector in the y direction. And how is this useful? Well, if we look at x hat, for example, let's say we call this vector, we've called this vector x hat. Well, this vector is an alpha, it's on the unit circle, firstly, it's an angle alpha anti-clockwise from the x prime axis because x prime is alpha clockwise from x. So x is alpha anti-clockwise from x prime. So because it's on the unit circle and it's this angle alpha, we could say that x hat is equal to cos sine of alpha and sine of alpha of x prime and y prime. And then we could do a similar thing for y hat. But this one's a bit trickier, so it does take a bit more time to process this idea. What I'm going to do is I'm going to extend the x prime axis here, and then this is going to be our minus x prime. And then what I'm going to say is that our y hat vector, if you notice it, again, it's on the unit circle, but its angle alpha is from the y prime axis. So what we've got here is that it's in terms of its x prime coordinate, so it's x prime coordinate if we did it here. So I've drawn this line here to be parallel to this x prime axis. So because this is opposite, this must be a sine. And because it's in the minus direction, we're going to need to write this as minus sine alpha. So again, it's opposite the alpha, so that's where we've got a sine. And then we've also got the fact that it's in the negative x prime direction, so we've got this. Now, in terms of y prime, it's the y prime term is adjacent to the angle alpha here. So y prime, this point here, its y prime coordinate would be adjacent, so it's going to be cosine, and it's in the positive y prime direction, so it's cosine of alpha, y prime. And so we could use these expressions to actually find a relationship between cosine theta plus alpha and sine theta plus alpha with cosine theta and sine theta. So what we're going to do here is we're going to write the fact that r is cosine theta of x hat in terms of that x coordinate, and then it's sine theta of y hat. And then what we're just going to do is substitute our expressions here. So this is r is equal to cosine theta, and then x hat is equal to cosine alpha x prime hat plus sine of alpha y prime hat, and then plus sine theta, and we have that y hat is equal to minus sine of alpha x prime hat plus cosine of alpha y prime hat. And then expanding this out and collecting like terms, we have cosine theta cosine alpha, and then we have minus sine theta sine alpha, and this is for the x prime hat term. And then for the sine term, or well, for the y hat prime term, we have, I'm going to write it with the sine theta cosine alpha part first, and then plus cosine theta sine alpha. I'm going to write that second. And what we can now say is that we've related r to x prime and y prime. So we've written it in the basis of x prime hat and y prime hat. So these must be equivalent to what we got here for cosine theta plus alpha and sine of theta plus alpha. So this term must be cosine theta plus alpha, and this term must be sine of theta plus alpha. So we found an identity or relationship between cosine theta plus alpha and sine theta plus alpha with the theta and alpha angles. Now let's have a look at, we could do this for theta minus alpha. So what we could do is we could write our axes again like so. So we have y, we have x, and then we have y prime, x prime. And what I'm going to do is for my point P, I'm going to define the angle theta now to be from the x prime axis. And I'm still going to keep this angle. So I'll draw it in a consistent color. Call this angle of x prime to alpha, alpha in the clockwise direction. So this point P here. So we're now in a different situation, but we're still using the relationships and things that we found in order to determine things. We have that R is equal to cosine theta and sine theta because it's on the unit circle. Again, let me just re-emphasize that. So it's on the unit circle. And so its coordinate here would be, this is cosine theta in terms of x prime, and this is sine theta in terms of y prime. But then if we wanted it in terms of x and y, well, what angle is that to x and y? Well, that angle here is theta minus alpha. So this is cosine of theta minus alpha and sine of theta minus alpha in terms of x and y. So I've essentially flipped the script on this. So I've redefined that angle theta to be from x prime, and then now the angle between x and y is theta minus alpha. There's another manipulation we could have actually done based on what we did earlier by just redefining theta plus alpha to be some angle, let's say u, and then theta would be like u minus alpha. And then you could try and find some relationship there to get it. So that's another way you could do it. So you could look into that, and it would just require some algebraic manipulation and simultaneous equations. But this is another way of achieving this using geometry again. So what we could do here is we could say that, well, we know from earlier that x hat was equal to cosine alpha of x prime hat plus sine alpha of y prime hat. And then we also know that y hat was equal to minus sine alpha of x prime hat plus cosine alpha of y prime hat. And what we could do is, using a trick that you would have learnt from simultaneous equations, is always useful to use previous knowledge, especially from GCSE studies or earlier in your secondary education. We can try to find or isolate x prime or y prime by getting rid of the other one. So what are we going to do here? We're going to multiply the x prime hat term by cosine alpha. And then this is going to give us cosine squared alpha x prime hat plus sine alpha cosine alpha y prime hat. And then we're going to multiply the y hat term by sine of alpha. So we've got sine of alpha y prime hat is equal to minus sine squared alpha x prime hat plus sine of alpha cosine alpha y prime hat. Then what we can do is take one away from the other. So we've got, so we could take one away from the other. So we've got cosine alpha x prime hat minus sine alpha y prime hat. And then this is going to equal cos squared minus sine squared. So this becomes this is equal to cosine squared alpha plus sine squared alpha, which is equal to 1 of x hat, and then this is plus 0. So what we've got is this relationship that x hat is equal to cosine alpha of x prime hat minus sine of alpha y prime hat. Now, what do we want to do if we wanted to find y hat prime? Well, we need to just get rid of x hat prime. So I'm going to multiply x prime by sine. So I'm going to multiply x prime by sine. Sorry, this is meant to be x hat. Sorry, I've just noticed the notation here. So this is meant to be that x was equal to this and y was equal to this. So this is x minus y. And then this term here was meant to be x prime. So apologies for the confusion there. So it's just an abuse of notation. So x hat prime is equal to this in terms of x hat and y hat. And so what we're going to do for y hat prime, so in order to get y hat prime, we need to get rid of x hat prime. So I need to multiply x hat by sine of alpha, and then y hat by cosine of alpha. And then what we get from this is, so we have here that sine of alpha x hat, and then we have cosine of alpha y hat. So this part becomes sine alpha cosine alpha x prime hat plus sine squared alpha y prime hat, and then this part becomes multiplying by cosine alpha minus sine alpha cosine alpha x prime hat, and then this part becomes plus cosine squared alpha y prime hat. So now if we add these together, we get sine of alpha x hat plus cosine alpha y hat. And this is equal to, well, this cancels out, and sine squared plus cosine squared is 1, so we just get y prime hat. So we found this expression for y prime hat now. So sine of alpha x hat is cosine of alpha y hat. And now all we have to do is substitute this in to our expression for r. So in our new expression for r, it was cosine theta in terms of the x prime hat, and it was sine theta in terms of y prime hat. And so what we get is that r is equal to cosine theta of cosine alpha x hat minus sine alpha y hat plus sine theta times sine alpha x hat plus cosine alpha y hat. And then collecting like terms, we get cosine theta cosine alpha plus sine theta sine alpha x hat. And then this part will become plus sine theta cosine alpha, again using the second term first, and then minus cos theta sine alpha y hat. So this must be cosine of theta minus alpha, and this must be sine of theta minus alpha, because we've written our vector r in terms of x hat and y hat. So we could match this to this cosine theta minus alpha and sine of theta minus alpha. And so we found an identity for the theta minus alpha term. So we have here that cosine of theta plus or minus alpha, collecting everything we've done, is cosine theta cosine alpha, and this would be minus plus sine theta sine alpha. So when there's a plus sign inside that cosine theta, there'll be a minus sign between the cos and sine. And then when there's here a sine theta plus or minus alpha, you get sine theta cosine alpha plus or minus cos theta sine alpha. And these are identities. Now, if we wanted to get tan theta plus alpha or minus alpha, this wouldn't be too difficult. It would be tan of theta plus or minus alpha equals sine theta plus or minus alpha over cosine theta plus or minus alpha, using the definition of tan or its relation to sine and cosine. So this would be sine theta cosine alpha plus or minus cosine theta sine of alpha over cosine theta cosine alpha minus plus sine theta sine alpha. Because we want to get everything in terms of tans, we want to get sines over cosines. So we're going to divide by cosine theta and cosine alpha. So dividing through by cosine theta and cosine alpha, what we get is sine over cosine becomes tan theta, cos alpha over cos alpha is 1, plus or minus, so cos theta over cos theta is 1, sine alpha over cos alpha is tan alpha. Cos theta cos alpha divided by cos theta cos alpha is 1. This becomes minus plus sine theta over cos theta is tan theta. Sine alpha over cos alpha is tan alpha. And we've derived the double angle identity for cosine, sine, and tan. So with these, you could then find relationships or ways to get, you could then use simultaneous equation type tricks to find cosine theta cos alpha, as in one simple example would be cosine theta cosine alpha would just be if I had cosine theta minus alpha, that will have a minus sine sign. And then if I had cosine theta plus alpha, that will have, sorry, this will have, theta minus alpha will have a plus sine sign, and then theta plus alpha will have a minus sine sign term. So if I add those together, I will get rid of the sines, the sine terms. So you just get cos theta cos alpha, but there'll be 2 copies of those. So I'll just need to halve that. So that's a way that I could get this type of relation. And you could do something similar for sine theta sine alpha or tan theta tan alpha, things like that. It just uses manipulation of these expressions to cancel out certain terms that are common to both. And it uses these tricks that, again, when you learn these and get familiar with them in earlier parts of education, you can then exploit them later on, because maths, physics, chemistry, engineering are quite linear subjects. So anything that involves algebra and just building on your earlier foundation, you can then use simple tricks to get yourself out of tricky situations or tricky problems. Most things can be broken down into much simpler problems, and then it can make a very difficult problem look easy eventually. So hopefully these derivations for double angle formulae have made sense. If you have any questions, please do let me know in the comments, or any feedback, anything you'd like me to showcase more of in these videos or pay closer attention to. I'd appreciate the feedback. But hopefully it's all made sense, and you see these intuitive ways of deriving these double angle formulae. Thank you.